Recording, yeah.
A very warm good afternoon to all of you. This is Vivek Dangi, first year student of Deen Dayal Upadhyaya College, pursuing business management studies from this esteemed institution. Today, we have virtually been assembled on Zoom platform to attend a national webinar on a very interesting topic, that is computational gastronomy, a data science approach to food innovation. Why do we eat what we eat? This is a question that is worth a lot of debates. In today's session, I bet the doubts regarding our food would get clearer than ever. Moving on, I would like to introduce the ideals of IIC. Our respected teacher convener of IIC DDUC chapter is Dr. Ravinder Kaur ma'am. The Ministry of Education, through its Innovation Cell, launched the Institutions Innovation Council program for higher education institutions to systematically foster the culture of innovation and startup in the institutes. We have conducted several sessions on innovation and entrepreneurship in the past few months and received an overwhelming feedback from the audience. We continuously strive to promote an innovative environment in our college. If this spark interest, please do check out our social media handles. I now request Dr. Ravinder Kaur ma'am to introduce our esteemed resource person of the day.
Thank you, Vivek. Thank you so much. A very warm welcome, Professor Ganesh, and all the participants who've joined our webinar, the computational gastronomy, which is the emerging data science that blends food with artificial intelligence. We are really happy to have an eminent person like Professor Ganesh, who's done a lot of work in this field. Now, all of us know that cooking forms the core of our cultural identity, other than being the basis of nutrition and health. The increasing availability of culinary data and the advent of computational methods for their scrutiny are dramatically changing the artistic outlook towards gastronomy. As Vivek said, starting with a seemingly simple question, why do we eat what we eat? The data-driven research conducted in the lab by Professor Begler and his team, they have explored various things and come out with traditional recipes, their flavor compositions, and health associations. And they have revealed the culinary fingerprints of regional cuisines across the world, starting with the case study of Indian cuisine. Application of data-driven strategies for investigating the gastronomic data has opened up exciting avenues, giving rise to an all-new field of computational gastronomy. This emerging interdisciplinary science asks questions of culinary origin to seek their answers via the compilation of culinary data and their analysis using methods of statistics, computer science, and artificial intelligence. And today we have Professor Ganesh Begler from Triple IT Delhi, who is working a pioneering work in this. And we are really blessed to have him here. And we all look forward to a very insightful, a very intriguing topic on computational gastronomy in food innovations. So we are really looking forward to this insightful session. Over to you, sir, and the platform is all yours.
Thank you. Just confirm whether my slides are available to all of you.
Yeah, the slides are visible.
Very good. Thank you. So a very warm welcome once again to all of you, and thanks for having me as part of this particular seminar, national seminar, where I would be very happy to share our excitement of in doing this interesting and exciting work, which has led to at least one startup so far, and hopefully will lead to a couple of other startups as we go along. So I'm going to tell you the story of computational gastronomy as it unfolded in my lab for the last roughly 6 to 7 years that we have been working. And while doing this, I'll be taking an approach of giving a narrative, telling a story of what has happened in a step-by-step fashion way back in 2015, and what is the future that we foresee for this new niche called computational gastronomy. So computational gastronomy, I'm going to present a data science approach to food innovation. So let me take you forward. I am from IIIT Delhi. I am part of Department and Center for Computational Biology. At IIIT Delhi, we are working on various aspects of computer science and its applications in allied areas, which includes computational biology and computational gastronomy. I am anticipating that this audience is going to be heterogeneous in terms of their background, in terms of their training. They may be from MBA background or from sciences or arts, etc. And thereby, I'm trying to keep this talk at a level which is as accessible as possible. However, even if you have any queries at any point of time, you may please keep them in your mind, and you can raise those queries towards the end of my talk. I'll be giving ample time for question answer session. Now, first of all, you might be wondering, this professor who is going to talk to us about computational gastronomy, which is about food, must be a foodie. And therefore, he must have thought about working about food and using computers for dealing with food. Then you can be definitely wrong about it if you are thinking about that. As a teenager, I was an aspiring astronomer. I always wanted to be an astronomer and astrophysicist and hopefully discover new stars. That's what I wanted to do. But fate was not meant to be in that manner. And I ended up taking a journey which actually started from training in physics. At the left bottom, you will see where I got trained in physics at my bachelor's and master's level, followed by an MTech degree in computational techniques, and then PhD in computational biology. So it was a diverse training that I've had in physics, computation, and biology, which has prepared me to investigate questions of interdisciplinary nature. And I strongly believe that to be able to be innovative, to be able to come up with interesting innovations, you need to have diverse backgrounds. That's one more input from my side, at least from my experience, that gather experiences from diverse domains, which would help you in coming up with interesting ideas as you move along in your career. So after that, after my PhD, I have worked at NCBS, National Center for Biological Sciences, and Max Planck Institute of Molecular Genetics, where I did my postdocs in the area of computational neuroscience and structural bioinformatics, wherein I spent a year at Berlin before returning to India, and have worked at a couple of institutions in India, including at IIT Jodhpur before coming to IIIT Delhi. In fact, this journey of computational gastronomy started at IIT Jodhpur, roughly 6 or 7 years back, when I started investigating interesting questions related to food, cuisine, and food pairing pattern in the Indian cuisine. My lab is called a complex systems laboratory. We try to look at biological complex systems, protein structures, cellular mechanisms, neuronal connectivity, and food also included in that, in a very, very unique manner, trying to see forest from the trees, trying to understand, putting together the trees, putting together the smaller elements that we have disentangled from the larger system, and trying to understand how the system as a whole works in a holistic fashion. That's what we are trying to do. And while doing so, we come across this property of sum of the parts is not the same as the whole. And this you can appreciate by understanding that, look, even if you understand how an individual neuron works at a physiological level, when a large number of them, 1,000 or 1,000,000 of them are put together, the property that arises out of it, memory, cognition, consciousness, etc., are way beyond our comprehension even today, despite the progresses made in science. So I would be trying to give you a sense of this emergent properties that are found in various parts of our studies, including food, which is the focus of today's talk. So what is computational gastronomy? What is the definition that I would like to make if I'm the founder of this area? So computational gastronomy is a data science that blends food with data and the power of computation so as to achieve data-driven food innovations. That's how I define computational gastronomy to be. The idea here is to bring together disparate entities such as food, data, and computation to come up with interesting innovations. And I'm going to point out to what are the innovations that we are coming forward, which touch upon different aspects of food, gastronomy, and even health for that matter. When we look at food, you and me, think about what you had today in the breakfast and what you intend to have for the lunch at home or wherever you are located in the hostels, etc. Regardless of what you think about it, food is an artistic endeavor. Food is considered to be an art. It's a magical process of transforming raw ingredients. And the protocols for transforming raw ingredients, called recipes, have been imbibed into our cultures over a long period of time. Whether it is Indian cuisine or whether it is Italian, Mexican, Chinese or Japanese cuisine, all of these have imbibed different practices of putting together ingredients in an idiosyncratic manner to be able to come up with delicious recipes that we tend to have on a day-to-day basis, right? So this is an art. Talking even thinking about how to convert this art into science is often detested. It is not liked by many who like the whole notion of artistic endeavor, which is surrounded around the food. But I believe that today we stand in 21st century where data is making a huge difference to our lives. Think about how we used to live roughly 20 years back. Those of you who are more than 20 years old can think about how the life was 20 years back. There was no Google, or Google had just arrived, I would say. There was no Google Maps. There were no Ubers and Olas. There were no Zomatos and Swiggies and similar applications which are extremely data intensive, including Netflix and Prime Videos. They were not there. Nor was railway reservation system as sophisticated as it is today. There was no online railway reservation system. Just to give few examples, no weather prediction was as good. Weather prediction weren't as good as they are today, happen to be there today, right? All of these have improved in understanding by introduction of large amount of data and computational techniques, which are largely part of the artificial intelligence paradigm, the machine learning, artificial intelligence, natural language processing paradigm, which have changed our life dramatically. So my claim is that data is going to change our life dramatically, even in the context of food. Talking about food and cooking, interestingly, it has been considered that cooking is central to the evolution of disproportionately large brain sizes that Homo sapiens, we humans, tend to have. We humans have disproportionately large brain size vis-a-vis any other species that is living on the face of the earth compared to our body size. And it has been argued that cooking is the central theme which has contributed to increase in the brain size. And this argument is made in a book called Catching Fire: How Cooking Made Us Human by Richard Wrangham, who says that cooking is the very essence of being human in the first place. Cooking opened up enough time from foraging, from chiving, allowing us to eat cooked and processed food, and thereby letting the brain space increase over time, over evolutionary time, and thereby evolving a species which today dominates the face of the earth. And those of you who are interested in the past of the species of Homo sapiens should definitely read the book called Sapiens, which talks about the past of humans in general. Ironically, while cooking has been extremely critical and food has been extremely critical towards contributing towards increase in the brain size, it has also been central to the various lifestyle disorders that we tend to face today. This is a very interesting cartoon which shows evolution of human beings from an ape to being an evolved species which is dominating the face of the earth, but at the same time has been plagued with lifestyle disorders such as obesity, type 2 diabetes, cardiovascular disorders, and similar. What are the factors which contribute towards these lifestyle disorders? If you ask this question, turns out that there are many things that pop up in our mind. The genetics, the background of genetics which might be responsible for causing these diseases is one of the factors. the social ambience that we have, the lifestyle that we live, the sedentary lifestyle that we typically tend to live these days, and importantly, diet. Diet is a key factor which plays a single most important role towards driving the lifestyle disorders that we are facing today. Therefore, it is important to investigate diet from a data-driven perspective is the argument that I'm trying to make, standing in 21st century in the presence of computational techniques that are available today, thanks to the revolution that has happened in the domain of computation, AI, and allied areas. In my opinion, different aspect of food, like different aspect of geography, have been digitized in terms of maps. Different aspect of, let's say, railway reservation system have been digitized and thereby transforming online reservation system compared to the physical reservation system. Similarly, in the context of and weather prediction, think about that presence of a large number of weather meters which are measuring temperatures and humidity, etc. parameters, weather parameters at different places. In 21st century, food is going to get transformed by introduction of data, by making food computable. Different aspect of food will be made computable. And no aspect of life can be transformed into a data science unless you look at quality curated data of that domain. And when you talk about food, these are the domains that we have looked at so far. One is traditional recipes. What we consume on a day-to-day basis are traditional recipes. So we need to have quality curated data of recipes, the traditional recipes. Further, we need to look at the taste aspect of it. What are the flavor molecules which are found in the ingredients that go into the recipes, and what are the flavor attributes, taste attributes, odor attributes that they tend to have. Then the nutritional value, which is an important component, which is an important reason why we consume food, because we want to gain nutrition, energy out of it, vitamins, minerals out of it, that needs to be accounted for as part of the food endeavor, or converting food into a data science endeavor. And finally, the health impact. How do different ingredients like ginger, tomato, potato, and think about any other ingredient that goes into the recipe impact our health? You need to consider that in a holistic fashion as opposed to seeing in a piecemeal manner. All of these need to be seen from a data science perspective. And that's what we have embarked upon in the last 7 years. We have been building data resources such as RecipeDB and FlavorDB, where DB stands for database, where we are trying to gather data of recipes from across the world. So RecipeDB is a comprehensive repertoire of 118,000 recipes from across the world, including 26 world regions and 84 countries, where we have gathered these data from in a very, very structured manner, where each ingredient, quantity, unit, temperature, processing, which has been happening on the ingredients, such as boiling, frying, sauteing, and the kind of utensil which has been used has been very well extracted and documented and is available in a searchable fashion. So for example, if you wish to look for Italian recipes which use potato but don't use onion, which use cheese but don't use, let's say, chili, you can actually search for them using our interface of RecipeDB. And similar kind of searches can be done using the nutritional values as well, which are estimated nutritional values available on RecipeDB. In a similar manner, we have investigated the taste or the flavor basis of the ingredients that go into the recipes. The milk, the fruits, individual fruits such as tomato, onion, the apples and the oranges, and the fishes. Just think about any ingredient that you can think in each of these category which has been flashed in front of you. You would have ingredients of that category, around 937 ingredients that we have listed, and their flavor molecules and their flavor attributes. What molecules are present in this and what are the flavor attributes of those molecules. Each of that has been recorded and we provide a tool for food pairing, which you will come across very soon, for doing food pairing in these database as well. So this is just an illustration of two of the different aspect of food that we have tried to quantify, convert it into a data science such that we can investigate it from a data science perspective. Now I'm going to tell you a story. So I'm going to take you into the past, 2015 IIT Jodhpur, where this story began. And then I'm going to tell you about the future in the second part of my talk. So in the first part, we started asking a very simple yet challenging question. And that was, why do we eat what we eat? Is there any answer for that question? Just think about it. In case you have any answers or anything, you can write it in the chat box or raise your hands, whatever, doesn't matter. Even if we won't stop the flow of the talk, I would know that people are listening and you guys are responding to it. So I believe that most people are unaware of why are we eating, what we are eating. Today we had paratha or dokla or idli or a dosa or whatever you had in the morning for breakfast. If you ask the question about why do we eat what we eat, turns out that it's a very, very difficult question to answer. But in principle, everything that we eat as human beings eat is nothing but combination of ingredients. We combine ingredients in an idiosyncratic fashion to create a recipe out of it. Unlike other animals, the rats, the pandas, the dogs and the cats, think about any other animal, wild animal, they are not attuned to putting ingredients together, processing them and eating them. They eat whatever is naturally available to them, or those animals which are domesticated would tend to eat whatever is available to their masters. But then human beings are very unique. We try to combine ingredients in a specific manner and eat them. And thereby we have created cuisines in different parts of the world, like putting together symbols and vocalized symbols and making a language out of it. Putting together symbols and making a language out of it has created unique languages in different parts of the world. Similarly, putting together ingredients in a different way, in a different combination, has created different kind of cuisines across the world. There is an Indian cuisine, and you would disagree with me at some point of time, and you would say that there is nothing called Indian cuisine. There is a Bangla cuisine, there is a Maharashtrian cuisine. Some of you might say that, oh, within Maharashtra, there are multiple cuisines, if you wish. If you look at different parts of cuisine, the Vidarbha, the Marathwada and different parts of Maharashtra, and same would be true for other parts of India as well. Essentially speaking, one is trying to say that for every 100 kilometer, the cuisine changes, roughly speaking, like language, and the dialect at least changes from one place to another place. So we changed this question to a simpler one to ask, why do we combine ingredients in our recipes the way we do? That's a question we wanted to ask. And I would wonder if any one of you has any answer for this question, right? Right. I would like to present you an answer to this question. Though some of you may or may not have answer to this question, you may vocalize later. But the answer to this question was given by none other than a chef called Heston Blumenthal proposed a hypothesis called food pairing hypothesis. He said that ingredients that taste similar tend to be used together in our recipes, the traditional recipes. And this is where he proposed the first ever time the food pairing hypothesis. And this came with his experience of food pairing in typically European cuisine. And we wanted to investigate whether this hypothesis is true in the context of different world cuisines. And the first ever study that was done way back in 2011 showed that indeed food pairing hypothesis is true for most of the Western cuisines. The North American, Latin American, Southern and Eastern European cuisines tend to have recipes such that ingredients which are similar in taste actually are used more frequently than those which are dissimilar in taste. That's what it was shown. And here, similarity in taste is quantified by looking at the flavor molecules which are present in them. Just to give an illustration here, coconut has got certain number of flavor molecules. Let's assume it has got 112 odd molecules. And for the sake of illustration, an onion has got another 170 molecules. We shall look at what is the overlap, how many common molecules do they have. The higher the overlap, the more is the similarity in the taste is what our assumption will go as. Okay, and that provides us a basis for moving forward and asking this question in the context of Indian cuisine. This was not investigated until recently. We looked at Indian cuisine, which is a potpourri of cultures with rich culture and rich and diverse culinary heritage that we tend to have in this part of the world. It's pretty culture rich, and it has health centric dietary practices. So the question is whether the food pairing hypothesis is equally true in the context of Indian cuisine or not was to be investigated, was to be checked out. And nobody had done this until we started doing it. So we wanted to collect the data of Indian recipes. So you can think about it, about what are the places from where we can collect this data, right? Where we can obtain this data from. So we started obtaining this data from various online resources, which was easier to do as a computer scientist, as opposed to collecting it from hard copies of the book or by getting these recipes directly from verbally recited by some people who actually cook. Okay, so we started collecting it from online repositories such as Tarla Dalal, sanjeevkapoor.com, and you have ndtv.com and similar repositories, of which we stuck to tarladalal.com because it had fantastic classification and annotations of recipes, such as a recipe belonging to whether it is from Bengali, Gujarati, Jain, Maharashtrian, Mughlai, Punjabi, Rajasthani, or South Indian as a broad class. And we collected these recipes. We had 2,543 recipes. I don't know for you whether this number seems a large number or a small number, but at the time when we started this in 2014 and 15, this seemed a fairly large number for us to investigate. These recipes were composed of 193 odd ingredients which belong to different categories. They were pulses, spices, vegetables, nuts and seeds, fruits, flowers, fish and seafood, cereal and crops. And ingredient categories were exclusive. One of the any ingredient would be categorized into one of the exclusive category. No other category can be tagged with it. Okay, for the sake of simplification. And that's the way we compile the data. And that's the way we have now the data of recipes, the ingredients in them. But then to be able to answer the question about food pairing, we need to look at the flavor basis of the ingredients. Because whatever we are consuming, onion, tomato, chili, tamarind, etc., we are consuming by virtue of the taste and odor that they present to us when we taste them or smell them. By virtue of interacting with our olfactory so-called and gustatory machineries, the smell and the taste machineries, we tend to have the sensations which go into deciding whether such an ingredient will be chosen or not chosen to be a part of a recipe. Therefore, we started collecting the data of molecules or flavor molecules which go into these ingredients. So for a large number of ingredients, at that time 193 ingredients, we compiled the data of flavor molecules that go into those ingredients like the tomato, curry leaf, spinach, chili, egg. Think about any ingredient that typically goes into a recipe, and we could compile this data from existing literature such as PubMed, PubChem, and Fenori's handbook and similar kind of resources that are available on online and offline. So having compiled the data of A, recipes, B, ingredients present in them, their categories, and flavor molecules in the ingredients, we have tripartite data, as it is called in data science, which can be now investigated for food pairing phenomena. How do we do that? Well, you look at a cuisine, and a cuisine could be said to be a set of recipes, recipe 1, 2, 3, all the way up to the last recipe. And each of the recipe can be broken down, such as the one which has been shown here, ith recipe, has been broken down into its constituent ingredients, a caricature coconut chutney that has been shown here, wherein you have coconut, onion, chili, and curry leaf only as the 4 ingredients that are forming this coconut chutney. which is not true, by the way. This is just an example here. And now we can make pairwise combinations of these. In the bottommost part, I'm showing you the pairwise combinations such as onion and coconut and chili, curry leaf and chili, etc. And for each of these pair, we can ask a question about how many molecules are common between these two ingredients. That's a very straightforward numerical answer that we can obtain by asking this question. And you take an average of all of this, that will give us average number of shared flavor molecules across all pair of ingredients in the given recipe. And that is nothing but our food pairing. It's a food pairing index of a recipe. And by taking mean and standard deviation across all the recipes, we can get the food pairing index of the whole cuisine as well, by the way. So that way, we are trying to quantify what is otherwise qualitative, the taste and the odor aspect of a recipe in terms of the food pairing. By the way, I have no thoughts on, I don't think that food pairing reasonably justifies the taste and odor, which is a qualitative attribute. However, it does provide us a quantitative handle, which is based on empirical data of flavor molecules, recipes, and ingredients, which can be used further for investigating the food pairing principle. Why are we doing all of this exercise? We're doing this exercise because we would like to check whether the food pairing that is observed, the combination of ingredients that are observed in the real cuisine, is it absolutely random or is it having biases in it? Because given a bunch of ingredients, let's say a basket of vegetable, a basket of lentil, another of dairy products, another of fruits, etc., all ingredient categories, if a monkey were to enter into a kitchen, it would put randomly ingredients together to create recipes out of it and then make a cuisine out of it. That would be called a monkey cuisine or a random cuisine if you wish. It's a statistical counterpart. Monkey cuisine is the statistical counterpart of random cuisine, essentially speaking, same thing. What we are asking is that compared to such a randomized combinations of ingredients, in reality, given the same ingredient, what is the pattern? What is the bias, if at all any, in the real cuisine? That's what we wanted to ask. And as professed by Chef Heston Blumenthal, indeed, in the Western cuisine, it was found that there is something called uniform food pairing or positive food pairing, in which basically you are putting ingredients together as long as they are similar to each other. More the similarity of ingredient pairs in terms of shared flavor molecules, the higher is their probability of being used together in the cuisine, in a recipe for that matter, right? That's what was observed in the case of Western cuisines. What we did in the case of Indian cuisine allowed us to investigate food pairing pattern in Indian recipes, and what we found was a completely reverse pattern when we used Tarla Dalal's recipes. We found that Indian cuisine is characterized with a contrasting blend of ingredients, meaning lesser the sharing of the flavor molecules, higher is their propensity of being used in the recipes. That's what we observed. And that turned out to be an interesting observation to do, wherein Indian cuisine was found to be having a contrasting blend of ingredients vis-a-vis the Western cuisines, which are having a very different blend, which is a uniform blend, similar kind of ingredients coming together. With that, I would like to take you to the next historical component and next experiment, and a very, very important take-home message here. And then I will tell you about the future of computational gastronomy. We wanted to ask if there was any one category, such as spice, dairy, lentils, vegetables, fruits, etc., which might be explicitly contributing towards this food pairing pattern. So for that reason, we took the whole cuisine and, keeping everything else same, randomized ingredients of one category, for example, vegetables. So instead of spinach, you will have other vegetable coming up there. Instead of that vegetable, you will have something else coming up there from the vegetable basket itself. So this is the so-called intra-category shuffling, within category shuffling of ingredients that we do independently. First for vegetables, then again you start from the original cuisine and do it for fruits, Again, you start from the original cuisine, do it for the lentils, etc. When you do this, quite clearly, the food pairing pattern or food pairing index, may I say, which is found to be there originally, the blue dot represents the original food pairing index compared to the monkey cuisine, which has been shown up there, is expected to change. However, is not expected to change much. The reason being this, that all fruits are kind of similar to each other. That's the reason we are categorizing them as fruits, because they have similar kind of flavor profile. They have similar kind of sweetish, savory kind of molecules which are present in them. Whereas vegetables have similar kind of molecules in them. That's why we call them vegetables, etc. Thereby, we found that random shuffling within category, intra-category shuffling of ingredients doesn't change the food pairing index much. It changes it marginally from the original food pairing pattern that I had shown you earlier. Barring for one category, there was one category wherein if you were to shuffle that ingredient category, the food pairing pattern changes dramatically. It ends up becoming completely random. And you guys can guess about which category that would be. And in fact, I'll be happy if some of you actually pop up the answers in your chat boxes. Okay. I don't know whether you would like to do that or not, but I would take a second or two before I can answer the question. Incidentally, that category happens to be spice. The spice category of ingredients, when they are shuffled in the context of Indian cuisine, intra-category, one spice is put with another spice, randomly shuffled with other spice, turns out that the food pairing pattern changes in a dramatic fashion to become what it is shown here, right? Suggesting that the placement of individual spices in Indian recipes is extremely critical. Spices are the molecular fulcrum of Indian recipes. That's the conclusion that we draw from this particular experiment that we have made. And we went ahead and identified individual ingredients that contribute the most towards the contrasting food pairing, and found that among those were predominantly spices such as red chili, green bell pepper, turmeric, cumin, asafoetida, which is hing, coriander, garam masala, tomato, clove, and tamarind. All of these turned out to be among the top 10 ingredients apart from tomato, which contributed towards a food pairing pattern that has been observed in the Indian cuisine, suggesting that spices indeed are key contributors towards a food pairing pattern, idiosyncratic food pairing pattern that is observed in the context of Indian cuisine. We made this spoof on an Indian brand, so to say that spice is the taste of India, therefore, it actually characterizes the taste of Indian cuisine. That's what we concluded based on our experiments that we had done so far. So we went ahead and tried to find out each of the categories contribution, spice, vegetable, dairy, plants, etc., fruits, about how much do they contribute, and do they contribute towards contrasting or uniform food pairing. And when you put this in terms of a graph like the one which has been shown here, turns out that we tend to have a characteristic pattern which is nothing but the culinary fingerprint of the Indian cuisine. We call it as the culinary fingerprint, like DNA fingerprint, because similar to DNA fingerprint, which uniquely identifies a individual, culinary fingerprint tries to uniquely identify what are the specific patterns of ingredient combinations in a given cuisine, such as South Indian cuisine, Maharashtrian cuisine, Jain, Gujarati cuisine, Bengali cuisine, etc. I know there is a caveat here. Of course, South Indian cuisine is not a single uniform cuisine. There are multiple cuisines within it, not to mention sub-cuisines within it. But for the moment, just let us stick to this data that we have investigated, and we'll come to that problem of refinement of data and coarse graining of data in a short while. So culinary fingerprints were identified, and this paper was published in PLOS ONE, where we showed culinary fingerprints of Indian cuisine to begin with in 2015. This particular research was highlighted as an emerging technology by none other than MIT Technology Review, and was touted as the best of 2015 by the end of year 2015. So by December 2015, exactly 6 years back, or 6 years back, we were trending as best of 2015. This research ended up becoming very popular and got a lot of media attention from a variety of media portals, including the Washington Post, and the Geek Wire, Epicurious, and Huffington Post, and whatnot. It was in Indian press, it was in Times of India, it was in Hindu, as big data is changing the way we look at food. It was on the cover of Science Reporter, the magazine which is published by CSIR body, and it was highlighted at Indian Federation of Culinary Associations International Chef Congress, 7th Congress, as well as the 8th Congress that was held in Delhi. It is also part of a book called The Indian Pantry, followed by an article that was written by Veer Sanghvi in his column in Hindustan Times called Rude Food, and has been highlighted in a variety of outlets otherwise also. The academia was not far behind in taking notice of the work that we have done, and it became part of Chemistry World, which is part of Royal Society of Chemistry outlet, magazine, and it was part of this article called Currying Flavor, where our research was highlighted. Chefs and culinary practitioners were also not far behind in receiving our work with a lot of enthusiasm. Chef Garima Arora, who is a Michelin star chef, identified the importance of our work and relevance of that work for tweaking recipes. And the industry was, of course, came forward telling us that this is the sweet spot of the food. In the coming decades, the bridging of food with data and artificial intelligence is going to change it dramatically. The way we eat, what we eat, how we eat is going to change dramatically, is what was recognized over a period of time. That is the historical bit of the work that we have done. Now, let me tell you, before I take you into the futuristic part of it and conclude with the talk, let me tell you about some of the shortcomings, which some of you already noticed, probably. Because a cuisine that we define as a South Indian cuisine is obviously not a reasonable way of describing the South Indian cuisine. There is Tamil Andhra cuisine. Within Andhra, there are different parts of cuisine. Andhra's Telangana cuisine and Andhra cuisine themselves would differ from each other, right? And similarly, in different parts of India, for every few 100 kilometers, the cuisines would change. So should we not account for that? We should. So the coarse graining has been done for the purpose of investigating the cuisine for the first ever time, but that has now been taken to the next level, so as to do the fine graining of the data and go to the next level. Another thing that we should notice is that in the definition of food pairing, we are missing the properties of emergent phenomena, wherein two ingredients might have individual tastes, whatever they have, but when they are put together, the taste might be completely different. That's what is emergent property or emergent flavor that is coming out of the combination of ingredients. How do we account for that? Similarly, molecular level, molecules might have certain odor percepts and taste percepts, but when they are put together, the final percepts might be completely different. We need to account for that as well. So these are some of the questions that we need to account for. And this particular picture that has been shown in front of you is nothing but called Spherical Cow, which is a joke on mathematicians and physicists, which I am myself, wherein these guys, when they are asked to model a cow, start with an assumption by saying that, let's assume that the cow is spherical. Sometimes this assumption makes sense if you want to find out what is the amount of heat that is disseminated by the cow's body. But if you want to find out the locomotion of the movement of the cow, obviously this assumption is wrongly placed, right? So this is what this particular cartoon depicts, that Spherical Cow is the model that is right now going on in computational gastronomy. And computational gastronomy is where physics was in 16th century. We need to make a lot of progress before we can move forward and look into the future of the food, where food can be made computable and data-driven food innovations can be achieved. While doing and while showing this future of computational gastronomy, henceforth, from now onwards, what I shall do is to use three different portals. One is the recipes angle. The second dimension is that of the molecular angle. And the third is that of nutrition and health angle. I will try to show you what are the different innovations that are possible. And some of you who are interested in innovation, in fact, many of you, most of you who are interested in innovation, in creating startups, may have more interesting ideas than what I can think about using data science as the driving force for investigating food. So you may want to talk about that later as well. While we started with Indian cuisine, we went ahead and looked at the world cuisines. We started with only 2,543 recipes, but we ended up investigating more than 1,45,000 recipes from different parts of the world, 26 world regions as shown in the picture, color coded, and 84 countries which are not shown in the picture, but they are within the regions actually. Right? For example, the Indian subcontinent has been shown using single color, but it encompasses both the India and Pakistan and Bangladesh. Right? In a similar manner, we have different regions and we have compiled these recipes from different cultures and have looked at the culinary fingerprints, the data-driven fingerprints of these recipes. And this paper was published in none other than a computer science journal, International Conference on Data Engineering, where it won the Best Paper Award in Paris and was identified as a key paper putting forward the data-driven science of food for the first ever time on a global scale after initial investigations that have been done in a sparse manner. We went ahead and wanted to ask this question about evolution of cuisines. Think about it. Starting from agricultural revolution, cuisines have evolved over a long period of time. Over the last 15,000 years odd or so, they have evolved. They have changed. Question is, what are the similarities and dissimilarities of different cuisines? And how do they shape up over time? If you look at that part, turns out that there are certain cuisines which are similar to each other and certain cuisines which are dissimilar to each other, and there are certain distances. So we have found out this cuisine tree similar to that of a language tree. Language tree also tells you about what is the similarity in terms of phonetic as well as script wise distances between the two languages. In a similar manner, this will tell us about distances between the different cuisines by virtue of ingredient combinations that are found in different cuisines. And we found that, of course, some of them do make sense in terms of geocultural proximity, such as Japanese, Chinese, Korean, Thailand, and Southeast Asian cuisine, which make a single branch, while there are certain differences between them. There is, for example, a breakdown of European cuisine into Eastern European and dark countries, which is Germany and Switzerland. And other branch goes into Spain, Portugal, Greece, and Italy, which are shown in red and green respectively. So this investigation that we have done provides us very, very interesting insight into the past of the cuisines, tells us about how cuisines may have evolved, and thereby provides a handle to look into the potentially look into the future of the cuisine. Can we potentially guess about another 50 years down the line how the cuisines might look? Can we come up with a guess about that in different parts of the world? That would be amazing if we could do that. That would give us a power as an entrepreneur. It would give us a power of looking into the future and thereby being prepared with appropriate products if you want to make innovations out of that. So that's the outlook you should be taking out of this particular research that has been done. We have published this work already in ICD Decor as well as in Physica A, where we looked at evolution of Indian cuisines incidentally. One of the other direction that one can look at when you talk about recipes is that of how many recipes are there in the whole world. Can anyone pop the numbers just in case in the chat box? How many recipes are possibly there? Is it in thousands? Is it in 10,000? Is it 100,000? Is it a million? What's the number that you would like to peg? You can make a guess about it. Turns out that this number, most people would tend to peg it below a million. Okay, somebody says, Parun says it is billions. Thank you for popping up the number. All right. In reality, the number of recipes are documented recipes which are available is only in terms of a few million, nothing more than that, which has been documented and which is available for investigation. And even if you make it billion, doesn't matter. Okay, you can take it. Okay, the numbers are getting pushed up by a trillion or so, but even that number is short of the actual number of recipes that can be theoretically be generated. The number of recipes that theoretically be generated is of the order of 10 to the power 30, which is more than the number of stars that are there in the whole universe. And how is this number coming up? It's coming up because a typical recipe has size 10, which we have verified it by investigating all the world cuisines. So typically they would tend to have a Gaussian distribution. Recipe size distribution is a Gaussian normal distribution and has got an average size of 10 ingredients. And if you were to safely assume that there are 1,000 ingredients available for permutation and combinations, you would have 1,000 into 1,000 into 1,000 10 times 10 to the power 30, at least 20 to the power 30 recipes that are going to come out of it by permutations and combinations. And this number, by the way, is a smaller number because we are ignoring the fact that the number of ingredients is not 1,000, it's more than 1,000. It comes out to be more than, for example, you have to consider all kind of varieties of potatoes and tomatoes and chilies. If you consider that, it goes into 20,000 roughly, at least according to our data. Nonetheless, even if you stick to the safe and conservative figure, this number is dramatically large and gives us a potential for creating recipes using with the help of computer, new recipes altogether. Can you generate a novel recipe? Innovation in recipes has been left in the hands of human creativity and human intuition until now. Only chefs and culinary enthusiasts, those who play with recipes, are the ones who come up with new recipes, if at all, other than cooking the existing recipes. That has been happening for a long period of time. Question is, can computers, given the structured data of recipes, flavor molecules, and the patterns in them, be of help to us to come up with novel recipes altogether? Well, that's the question we are asking in my lab. And I don't know how many of you have seen this movie Ratatouille. At this point, I would like an hands up from you guys, thumbs up or point, in chat box. How many of you have seen this movie Ratatouille? Very good. +1. Thank you. At least some of you have given the +1. Yeah. So I know that those of you who have seen this movie would recall Chef Gustav keeps saying that anyone can cook. Thank you for giving the thumbs up. Anyone can cook. So the question is, can computers cook? That's a question we are asking in my lab, so as to come up with novel recipes which are in silico, which can be in potential be tested out in the kitchen and tried out in the population. And the idea here is to come up with a Turing test for chefs. I hope you understand the notion of a Turing test, which is basically a machine trying to fooling a real human being into thinking that the machine is a real human being. Okay, that's largely speaking the spirit of the Turing test is in computer science. In a similar manner, with the same gist, we are trying to come up with a Turing test for chefs, wherein we can possibly come up with a notion that we can pop up recipes, we can create recipes which are generated by a computer, and we have already created the first cut of that. It's called Ratatouille. Right now it is down. Just wait for 2 days and it will be up. We are in the middle of a publication and it will be up, the URL which has been shown in front of you, and you should be able to search for it, and you should be able to create recipes using this novel recipe generation app, where you can pick ingredients of your choice that are shown in front of you, or you can search in the chat box, in the text box, and then you can generate a novel recipe such as the one which has been created here, wherein you can have a bunch of ingredients, and now the new algorithm will have quantities also, as well as a set of instructions about how to process these ingredients to come up with a final recipe, including the serving instruction. So that is what we are intending to do in my lab, and that is a fantastic innovation where industry is interested. Industry today is interested in providing palatable recipes which are potentially tasty and in principle healthy. Can you actually make your life better, spend less money and make your life better by being healthy, by eating healthy, is the question that industry is asking, innovators are asking. And that question can potentially be solved with the help of novel recipes which are being generated by which will be potentially be liked by the population. That's the idea behind the whole notion of culinary fingerprint and novel recipe generation. The second dimension that I'm going to tell you about towards as I move towards the end of my talk is that of the flavor molecules. Until 2015 or 16, the data of flavor molecules was absolutely scattered. What we did for the first ever time was to create a comprehensive database of ingredients and the natural ingredients and the flavor molecules in them, which are available naturally, and their taste and odor attributes, food pairing phenomena, and searching facility in all kind of manner in this database called FlavorDB. It's a universe of flavor molecules and is sought after by industry heavily for commercial applications, apart from academicians who are using it for browsing it from the web interface that we are providing. The URL is at the bottom. If you search by FlavorDB, you will get it. The first link in Google will be ours, and you should be able to search it, do the food pairing if you wish to, and play with it. In the molecular space, we have also worked on coming up with thought of taste prediction. Given a molecule, small molecule, or now we are working with peptides as well, can you predict what taste would it have? Would it be bitter, sweet, salty, sour, or umami? We have focused on the bittersweet axis dimension and have come up with a classifier, a machine learning classifier published in scientific reports last to last year, wherein we have shown that it is possible to build state-of-the-art algorithms with accuracy which is touching 90% or more, wherein given a molecule, we can actually predict using the interface that has been provided with the URL that has been given at the bottom, wherein we can actually tell you what is the probability of a molecule being bitter, sweet, or tasteless. And that is what is taste prediction all about. And you can think about possible application of this. If you want to come up with artificial sweeteners, which will combat the epidemic of diabetes that we are sitting under, India is sitting under, the world is sitting under, you would need to have sweeteners which don't add calorific value, but at the same time provide us the sensory sensation of sweetness, which is what is highly desirable by us, Homo sapiens. So that's what is the dimension that we are looking at. And the last dimension, that is of health. How human body interacts with the food is extremely complex, giving rise to health consequences. And thereby, it has become over the time extremely common for us to see assertions which are contradictory, telling us something is good as well as bad for our health. Eggs are good or eggs are bad. Fat is good or is it bad? And similarly, you can think about any other ingredient that might have been popped in front of you in the newspaper based on research article, which is good or bad. So one way of dealing with this dilemma is that of looking at a large amount of data that is available in the public literature and compiling it together to come up with, to make sense of it. So first step toward this, we have created something called SpiceRx, which is a subset of a larger data set called DietRx, which I will be flashing you very soon, wherein we compiled the data of all culinary herbs and spices, around 165 of them, which are used in the recipes, their phytochemicals, their disease associations, and phytochemical disease associations as well. With that, we are able to investigate this tripartite data in an interesting manner to come up with potential solutions. And our conclusion was that culinary herbs and spices tend to have a broad spectrum impact on positive impact, broad spectrum benevolent impact on a variety of health parameters such as digestive system, cardiovascular system, nutritional and metabolic effect, mental effect, immune system related, endocrinic system, etc. And we showed this in a paper published way back in 2018 that broad spectrum benevolence of culinary herbs and spices can be concluded by looking at a large amount of data and by doing data-driven analysis of this biomedical literature. So this was a text mining, which is part of artificial endeavor, where we have investigated this and have created a comprehensive repository called DietRx, which has not only 165 herbs and spices, but close to 2,222 ingredients which are used in the recipes, their disease associations, which are mined from more than 38,000 research articles compiled from PubMed and Medline, and association, which is between the food and disease, which is represented either in the title of the paper or in the abstract in a single sentence. For example, a sentence which potentially says that the ginger is found to be having a positive effect against nausea will be represented as ginger nausea positive effect. That's how the food disease associations will be shown, whether it is positive or negative. Further, this data has been integrated using the chemicals which are present in the food, such as tomato, onion, chili, etc., as well as the linkages with the gene. The only linkage or the data association data that we do not have is that of the food gene data. The rest of the all associations, pairwise associations, are all present in DietRx. Again, this paper is under review and is available for querying if you wish to investigate it further. And we are working on applications for such a data that is available on food disease associations. In this case, I'm showing you only spices and diseases, where we can try and find out which are the spices which, when used together, will be most beneficial against a specific disease, such as cardiovascular disorder, diabetes, or similar disorders, such that we can come up with dietary interventions. That's what we are trying to work on. To conclude, I would like to tell you that all of this research is taking us towards a space where personalized nutrition is going to become possible. This research, which was published in 2015 from Weizmann Institution, shows us an interesting direction wherein one looked at effect of change in one diet, breakfast, which is shown on the top, in relationship with a lot of body parameters that were measured for a large number of subjects, around 1,000 number of people, where gut microbiome, the blood-related parameters, questionnaires, body mass index, and food diary were maintained, and they were measured against food consumed by the individual for one output parameter, and that was the postprandial glucose level, the increase in post-meal glucose. And that has obviously got consequences for type 2 diabetes. What they found is that from individual to individual, given the same food, same diet, exactly same food, has different effect altogether. Therefore, generic advisories which are given, dietary advisories which are provided, let's say for diabetes, are meaningless. And it is important for us to come up with specific personalized advisories, personalized nutrition advisories for individuals based on whatever they need to be eating, depending on their body type, gut microbiome, and other parameters that are associated with the postprandial glucose level. And they could build a machine learning algorithm, which is represented here as a personalized nutrition predictor. And in my opinion, there is an immense scope for repeating these studies in different parts of the world, because Punjabi people will like to eat Punjabi food and still be healthy or not have diabetes, let us say. And similarly, that is true for any part of the world, people in any part of the world, where they would like to consume food that they like and still be healthy. So we would like to do, or we would like to investigate this from different parts of the world to find out what is predicted to be healthy for different people and make personalized predictions for individuals. So in summary, computational gastronomy is a blend of food and artificial intelligence, where we are trying to look at food from a lens of data. We are trying to use the power of data science, power of AI to investigate food, to come up with all sorts of innovative applications, which includes coming up with new food and beverage designs, food beverage pairings, taste and odor prediction of small molecules and peptides, culinary fingerprinting of cuisines, which tells us uniqueness about individual cuisines, coming up with dietary interventions which can be derived from food disease associations, and potentially we are staring at a future in 2050 where there will be 10 billion people to feed. How do we sustainably feed from farm to fork? Is it possible for us to use the existing practices, agricultural practices and food practices for feeding the 10 billion people? The answer is most probably no. We need to change the way we are preparing our food in the farms or through other methods, grow them and distribute them and not waste them, and make it available in a manner which is palatable and healthy for a large population as big as 10 billion in 2050. So sustainable food innovations is another direction that can be taken towards using data-driven innovations by combining a large amount of data. I teach a course on computational gastronomy at IIIT Delhi, which is attended by around 100 students, typically speaking, in every semester. And these students are contributing towards creating, a culture of computational gastronomy, tools of computational gastronomy, databases of computational gastronomy, which will help us in driving towards a future which is data-driven, food which is data-driven. And I'm writing this book called Bite, the Digital Science of Food, which is a tentative title, which should be made available sometime soon, which is a popular science book, which talks about all my endeavors, including adventures that are done in the context of food. So to end, I would like to quote none other than Brilla Savarini, the person who wrote the book Physiology of Taste, who also coined the word gastronomy. What he said rings true even today. The discovery of a new dish confers more happiness on humanity than the discovery of a new star. I started by telling you that I was an aspiring astronomer and I wanted to discover new stars, but couldn't do that. And fate has brought me on this path of being a computational gastronomer and a founding father of this, wherein hopefully I should be able to discover new dishes to make humanity happier and healthier. So with that, I would like to stop my talk and would like to take questions from you, unless already there are in the chat boxes, and would leave it to the organizers to manage the question answer session. But I'm done with my talk. Thank you. Thanks a lot for listening patiently.
Thank you so much, Professor Ganesh. It was actually an intriguing and such a, I would say it was itself an innovative lecture. You talked about innovations, but I was awed how data-driven food interventions have been done and what extensive research you have done, like no words, and you have been given accolades for all your work and you rightly deserve them. And I was even like so surprised that you went through 180,000 recipes from 26 different countries, just saw what ingredients are used, what spices are used, how different cultural foods from different origin, and studying them and then coming out with a very important the conclusion that which molecules match, which do not match, and then what type of food can be used to for health purposes and everything. It's awesome, really. Thank you so much for such an insightful talk. I'll request once again to all the participants to kindly write their questions, queries, any doubts in the chat box if you have any. And please fill your feedback form. Okay, there's one question. How can data science change the nutrition content of food recipe?
Okay, let me answer this question in a big way. There are companies, I don't want to name them because of confidentiality that I am bound with, but there are companies which are trying to change the amount, the nutrition that you consume via the food that you have on a day-to-day basis. And for that, they would like to come up with new recipes which are basically palatable and liked by people. And for doing so, you can compile large amount of data. For example, these guys have played with recipes and know ratings of those recipes from various consumers from different parts of the world. Talk about Australia, UK, Canada, etc. So all of this data can be used in the context of let's say data science, in the context of machine learning, and make sure that people eat food that they like. Talking about ethics, which was a subsequent question that was asked by you, right? I must say that partly you can't just stop it. How ethical it is debatable. About how do you nudge people into eating a certain kind of a thing, and should you nudge or not is a debatable question, whether it is ethical or not. But today, data science stands at a place where a lot of interesting ethical questions are being raised. So this is one more question which will come up, whether it is ethical to do so or not so. But I can tell you that there is a power in data science to make the changes in your nutrition landscape. That I can tell you for sure.
I totally agree. There's another question. What are the thoughts you have when you want to innovate a new recipe?
Quite clearly, as I told you, the number of recipes that are potentially possible are far higher compared to what is actually available. So coming up with new recipes, in my opinion, as of now, will remain a, a combined job of a computer and a chef, because a computer is very good at learning patterns and popping up combinations which are more interesting, and a chef is good at using his or her intuition in deciding whether those combinations are good in making up a recipe which is of, let's say, Punjabi style or Maharashtrian style or Italian style or not, based on their experience, right? So in my opinion, it will enable the whole endeavor will enable people to come up with new recipes in a faster manner, as opposed to doing a lot of trial and errors, which is what people tend to do these days.
And you talked about novel recipe generation app also.
Yes, yes, we have developed this Ratatouille app, which is a novel recipe generation app, and we do believe that this app has potential for improvement further, which is what we are trying to do right now. And quite clearly, I must tell you also that when it comes to the innovation part of it, first of all, everything that we are doing here practically is innovative. The reason being that this has been an untouched area. This has been a virgin area altogether. Nobody has worked on this topic altogether ever. So for the last 7 years, I have been investing myself completely on this topic and putting my efforts to make the foundation of this particular area, right? The second part is that companies, we have already created a startup called Ayushla Cafe, and there are a couple of other companies that are going to come up out of these ideas. And thirdly, commercially speaking, there are a lot of companies out there, which includes Google Research all the way up to Sony AI, who are interested in using these applications for their gastronomic endeavors. So there is a lot of interesting thing that is happening here. Those of you who are interested, those who especially come from computer science, data science background, please do get in touch with me. I do have PhD position, internship positions, and summer intern positions, wherein you can indulge into some of the interesting work that we are doing here.
That's a wonderful thing. Thank you so much for that offer. There are certain questions. There's one question from Steve Rogers. He wants to know, can we collect data of the gut microbiome of any specific person and accordingly suggest personalized diet? And how do we know by data that whether some combination of food or spices is harmful for someone and could be harmless to the other person?
The second question is very difficult to answer as of now. But the first one, yes. In fact, as you ask, I'm in the middle of a conversation with some of my colleagues from Japan who are doing gut microbiome related data research, where idea here is to see if it is possible for us to come up with specific dietary suggestions based on gut microbiome of an individual, right? There are other similar kind of interventions which are being thought about in terms of using Ayurveda as a basis, for example, looking at the prakriti of a person, the Vata Pitta Kapha prakriti of a person, and trying to come up with a diet which is suitable for the individual. Exactly in a similar manner, gut microbiome is another factor which we know plays a huge role towards linking with food, and thereby we can come up with recommendations which are good, which are potentially beneficial for an individual. But so far, the second question is very difficult to answer. How do you come up with food combinations which are good for individual or not? Generally, I can give an answer which spice combinations are generally good or generally bad. But if you ask specifically for an individual, it's very difficult to come by with an answer as of now.
Okay. There's another question from Sai Sani. He wants to know that as we all are going through this pandemic, the COVID-19 scenario, can the contents of the food or the food recipe be changed so that we all have a better immunity and we can fight this pandemic?
In principle, yes. The only, I mean, advisory thing is that I don't want to advise anything specific here. What I do know is that some of the spice combinations which have been proposed by, for example, Ayurveda community are potentially known to be immune boosting. I don't want to proclaim any specific names here deliberately. You may want to dig it out yourself by doing literature search and all that. But yes, there are changes in the food that you can do by taking certain kadhas, as they are called as, which are known to be immune boosting. Potentially those changes can help you, but take my word on it, there is no empirical data to for it that it will be beneficial to you against COVID specifically. I would like to reiterate that we do not know whether the efficacy of these combinations or food that we are consuming, so dietary suggestions that are given, will be there against COVID-19 or not. So be warned against about it, and obviously take your vaccine, wash your hands, and keep safe distance. That's the best thing that you can do right now.
Very rightly said, but we all were having these kadhas during the first wave and second wave very religiously. I think that was amongst all of us, that we were taking different combinations, and so that they are immunity boosters. There's another question. What are your ideas about sustainable food development, and how do you say that food development is sustainable?
So as of now, the food development that we do, or food consumption that we do, is not sustainable at all. That's why I said that by 2015 we are going to have 10 billion people as opposed to 6 to 7 that we have today, and it is going to be extremely difficult to feed all of these people in a sustainable fashion, right? Therefore, we need to change the way the food is moving from farm to fork. The farms of tomorrow can be agroponics, if you wish. The farms of tomorrow would not be having the same kind of farming practices that are found today. I believe so. I strongly believe that the way we prepare our food in the agricultural land is going to change dramatically, without which we cannot feed 10 billion people. So the answer to your question is that as of now, the food development is not sustainable, and there are ways by which food development can be made sustainable by introduction of new technologies such as agroponics, by making urban landscape prepare food for us, by growing food in your kitchen gardens, right? By avoiding wastage of food as much as possible, by making use of technology for avoiding waste of food as much as possible, and by changing our food practices. For example, by changing our protein consumption from non-vegetarian food to something which is vegetarian, which is plant-derived, can help us a lot in making food sustainable. So these are some of the ways by which we can make food sustainable in times to come.
You've already told that your diverse background has really helped you, and your session is telling how passionate you are about your work. And I think you already have become a role model of some of the students, as is very evident from one of the questions which is asked by one of the students. He says, what efforts we should do if we want to be like you?
Okay,
so you have a compliment, a big compliment. I think you've already become a role model, and the persons want to ask, what all they should do, what all hats they should be wearing to become one like you?
So first of all, I'm grateful and for the comment and the compliment that has been given by anyone from the participant. You know, I don't know whether I am a role model or not, but I can tell you one thing for sure, that if there is anything that has made me successful, that has been learning from each of the experiences or each of the experiment that you do in your life. You know, for example, I liked doing computing. That's the reason I moved from physics to computer science. That was my passion, and that at that point of time I moved in that direction. Food happened serendipitously by doing a lot of experimentation, right? If you are a researcher, just in case you are a researcher, I would recommend reading a book called Anti-Fragile by Nassim Nicholas Taleb. Okay, wherein he recommends or he suggests something called barbell strategy for financial improvement. But however, this can be used for life improvement as well, wherein essentially you do research in a focused manner on one side. On the other side, you do diverse researches, small researches, which will give you probably a new direction altogether. That's how I ended up doing in IIT Jodhpur. I ended up doing research in a passionate manner, and don't leave your passion. That's one thing quite clear. Whatever you are passionate about, it can be food, it can be robots, or it can be extraterrestrial intelligence, whatever it is, just stay passionate about it and you will find your path. You may not end up becoming what you wanted to be as a teenager, like I did. As a teenager, I wanted to be an astronomer, but I still derive inspiration. And even today, I get talk invitations from these top-notch astronomical and physics institutions to talk about my journey from astronomy to gastronomy. So yes, that's
awesome.
What I would say.
Awesome. And very rightly said, follow your passion and you'll find your purpose.
Yes.
So that's the key. One last question from my side. What is your background? Like from what place you hail? What part of the country you hail from? And the food, like how have you been able to change the cuisine of that particular part? And have you seen something really different coming out of the data you got from your computational driven approach?
Right. Let me answer the first part, which is easy. That I come from South Maharashtra and North Karnataka zone. I am ethnically a Kannadiga, born and brought up in Maharashtra. So I do have multilinguistic and multicultural background. But that's where I come from, a city called Sholapur. That's where I hail from. And if you ask me whether I have experimented with food, I have done a little bit, much, I must confess that. My work largely has been confined to data-driven science and trying to create databases, repositories, and writing algorithms, and less about experimenting with food. But yes, along with in my home, that is, I've been experimenting with a little bit with food. That hasn't changed much of my food practices, I would say. I have only tried to imbibe some of the basic food practices in terms of what I should or should not eat in my diet. That is what I've tried to do. For example, avoiding sugary drinks and sugar is one of the major factors which I've learned not to do, avoiding that from my food, and the rest is basically eating traditional food is what I've been following for a long period of time, despite my indulgence into computational gastronomy.
And apart from actually finding recipes through computational gastronomy, do you actually cook also?
Good question. So I do occasionally cook. I don't do it on a day-to-day basis. And this is a common question that is asked to me. And I am always taken to task on this question.
Obviously, a person who is always busy finding new recipes, finding, taste with all the holistic things, and it should be healthy, nutritional, and tasty. Probably we would also trying it in the kitchen. So
yes,
that question becomes a very obvious one.
You're absolutely on the spot. And I do cook occasionally, and I have improved my cooking skills dramatically from the last 5 years of my no cooking experience that I had until then. And I also collaborate with chefs, by the way, to be able to make it more effective. I collaborate and talk to chefs a lot. and try to see if some of the recipes that we are coming up, novel recipes, if they can be tested out by some of the chefs, and if they can give their inputs in terms of their being realistic, palatable, and potentially healthy.
Awesome. Thank you so much. It was a very interesting, out of the box, I would say, topic and the discussion. I really enjoyed every single bit of it, and so did the audience. That's very evident from all the thanks which is coming in the chat box.
Thank you.
Before actually concluding the session and saying goodbye, can we ask the ICT person to take a screenshot? Can you make a few attendees, can you make them like their cameras, they can switch on their cameras and we can have
Yeah.
Yeah, and I'll stop sharing this, I think.
yeah.
I request everyone to switch on their cameras so that we can take a screenshot. Guys, please.
ICT, can we have a screenshot?
Yes, ma'am. Waiting for everyone to turn on the camera, please.
In the meanwhile, thank you to everyone, those who are saying thank you. Thank you once again.
And it was a pleasure this time, sir. We really had participants from different parts of the country. We mainly had participants from Gujarat, Punjab, Rajasthan, Tamil Nadu, Karnataka, and Hyderabad.
Wow.
Apart from different colleges of Delhi itself, there were participants from, apart from Deen Dayal Upadhyay College, there were participants from Bhaskaracharya College, Motilal Nehru College, Miranda House, Aurobindo College, and many more colleges. So we had good enough participation, and it was actually a worthwhile, I think, we say we have a treat to our taste buds. It was a treat to our ears listening to you. So it was indeed a very, very well planned, well structured, out of the box topic, which was delivered in a very out of the box manner, I would say,
Thank you.
and interactive also at the same time, connecting also at the same time. Thank you so much. It was a pleasure to have you, and I thank all the participants on behalf of the Institution Innovation Council, Deen Dayal Upadhyay College chapter, for your encouraging response, and I expect the same. I look forward to the same response in our future endeavors as well. Thank you so much, and wishing you all the health. Be safe, stay healthy, and God bless you all. Thank you so much, sir, and thank you so much all the participants once again.
All right. Thank you.
And to my
Bye-bye.
fellow colleagues, and especially to the
Thank you, sir.
ICT for the full-fledged cooperation. Thank you so much.
I will also request everyone to fill the feedback form which is necessary for the certificates for this session.
And thank you, Vivek, for being the host. Thank you so much.
Thank you, ma'am.